Hello guys and welcome back to this amazing channel. This is Abhinav. In this particular video, we'll discuss about the solutions of this bi-weekly contest 137. So basically, there were as usual 4 problems in this contest, and these problem number A and B were actually same, just having different constraints, and C and D were also same, right? By the way, I was just able to solve A, B, and C problem of this particular contest, so we will discuss the same here. The problem number D, I will try to solve after this video. If I will be able to solve it, I will for sure record a video for that also, right? Amazing. Let's discuss about these 4 problems. So as we say that A and B were the same problem, but just 2 different versions of that having different constants, and same for C and D also. The problem statement was exactly same, just the constants were different. For problem A and B, I was able to write the order of n solution, because of which my both the submissions were submitted. For problem number C and D, I actually wrote the order of n cube log n solution. Okay, not n cube log n. It is a order of n cube plus n square log n solution. Okay, and because of that, only the third problem I was able to submit, because in problem number D, according to the constant, what I can see, it was expecting order of n square log n solution. So I was not able to optimize this particular D problem. So I will try it after the video, right? Amazing. But yeah, we'll discuss about the first 3 problems of this particular contest. So let's start with the problem number A and B. Okay, so see, A and B, as I said, both have the exactly same problem statement. Only the time constants were different. So in the problem number first, basically, if you will see, the value of n was actually very low. It's just 500. So you can even write an order of n square time complexity solution. Okay, and because of which, not even I think n square, order of n into k solution, right? And because of which, that was the brute force approach for this problem, right? But if you will see the optimized approach, that is of order of n that I have actually solved. So I have submitted the same summation for both the problems, right? So let's see this particular problem, what it is. Problem says that you are having an array, right? You are having an array, and they are saying that what is a power array. So they are saying that a power array of an array is defined as the maximum element if all the elements of that array are consecutive and sorted in ascending order. Let me give you an example. Okay, for example, this is the array. Okay, for example, this is the array. Okay, this is the array. Okay, let's say that the array is like this: 2, 1, 3, 4, 5, 6, 4, 9, 7. Okay, if you will see, if this is the array, what is the power array? A power, sorry, not a power array, the power of an array. A power of an array is a number. It is the maximum number if all the elements of the array are consecutive and sorted in ascending order. Otherwise, it is minus 1. Otherwise, it is minus 1. Right? That is what we are having here. So if you will see here, what is happening? This is the array. This is the array. Right. What we will do is, let's take this particular array. And if I will ask you the power of this particular array, what is the power of this array? So the power of this array is 6. Why 6? Because you can see in this particular array, all the elements are present in the sorted order, first of all. And secondly, consecutive elements are present. 3, 4, 5, 6. Consecutive elements are there. So whenever this type of array comes, its power is the maximum number, or I can say the last number. Maximum last wali hoga na. So the power of this particular array is actually 6. Right, but if you will take an array which is not sorted or which does not contain consecutive element, then it is not the maximum, then it is minus 1. Then the power of such array is minus 1. For example, let's say this array. So if you will see this particular array, this is actually sorted to hai, but it does not contain consecutive elements. So there's a 1, after 1 2 should be present, which is not present, right? So its power will not be 4, its power will be minus 1. So basically, a array which is sorted and which contain consecutive element, the power of such array is the last element of that array or the maximum element. But if array is either not sorted or if it is not containing consecutive elements, then if it contains, basically, if it does not contain, it will be minus 1. What they are asking is, they are asking ki for every subarray of size k, we have to find the power of it. For example, let's say k is 3 here. तो if k is 3, you will see that for this particular first subarray, इसकी power क्या है? So power of this is -1. Why -1? Because it is neither sorted and it is neither neither having consecutive elements, right? Let's move forward. This is the second subarray of size 3. This is sorted, but it does not contain consecutive elements. So again -1. Okay, let's move forward. This third you will see is sorted also and contains consecutive elements also. So for this it will be 5, which is the last element of your sorted maximum one, right? Now moving forward, this will also sorted and consecutive. It will be 6 for this array. This is actually not sorted. Okay, and not even consecutive, no problem. This is also not sorted, not consecutive, no problem. So for both, that will be -1 and -1. And for last, you can see it is sorted, but it does not contain consecutive elements, so it is -1. So for this particular array, the answer will be this. This will be the answer array. Now how we can find it? See guys, sorted elements and in consecutive manner, that means कि every element ARR should be 1 plus than its previous elements. अगर ऐसा है, that means it is consecutive also and increasing also, sorted also. You can see it is a part of a consecutive array. Why? Because it is greater than 1 greater than its previous element. So the chain of elements where every element is 1 greater than its previous element, that is what the consecutive array is. For example, this is also a consecutive array, a part of a consecutive array. यहाँ भी ऐसा है, यहाँ भी ऐसा है, but here the chain breaks. Here the chain breaks, right? So if you are considering a subarray and in that subarray this chain is breaked of this consecutive element, that means it is not a consecutive subarray. Let me give you an example. तो हम क्या करेंगे? This is the nums that is given to us. Okay, let me show you now my solution, that what I have done. Okay, so our k is 3 in this particular case. What I've done is I'm given with this nums. अब देखो, if k is 1, then every subarray of size 1 having the power as the number itself. मान लो अगर k 1 हो ना, तो इस subarray के लिए 2 हो जाएगा, इसके लिए 1 हो जाएगा, इसलिए 3 हो जाएगा. तो basically then answer will be the array itself. So whatever is your nums array ना, that will become your answer also. That will become your answer also in this particular case. Second case will come when k is not 1. तो बाकी केस में क्या करेंगे? I will first of all create a ARR. एक ARR create करेंगे, you can see here, of the same length of n, and initially its value will be 0. So initially for this ARR, for every index value will be 0. Right. Now understand very carefully. Next point I am telling will be very basic. Now see guys, for every ith element which is not equal to I minus 1th plus 1 element, because according to our logic, if we want power of an array, then that value of that array should be 1 more than its previous element. The current index of the array should be 1 more than its previous element. If it is not, that means it is violating our law. We want an array where it should be sorted and consecutive. So jitne bhi indexes, whoever indexes are violating this law. Which law? The law where ith is not equal to I minus 1th plus 1. At that index, I will make my pointer increase. उस जगह में हम अपना pointer बढ़ा देंगे. Let me show you what I am doing. So you can see for the 0 index, there is no number before it. So 0 के लिए नहीं check करेंगे. So you can see I'm starting my array loop from 1. I'm going up to n. And if at index number I, the value is not equal to I minus 1 plus 1, then I will make my ARR I equal to 1. For example, for this particular index, it is not equal to previous element plus 1, so this will become 1. This is also not equal, this is become 1. This is equal to its previous element plus 1, so don't decrease. This is also sahi, this is also fine. This is not okay. This is also not okay. But this is okay, this is also not. Let's say if there is a 8, let's take a 8. Then here it will be 0 only, right? So for every index which is not equal to its previous index plus 1, I made my array ARR 1, right? This is what I did. Now what I will do? Now I have to check every subarray of size k. Up there is one thing which you have to understand very carefully. Very carefully. When I am having a error of I1, that means this one means this ith index is violating the law for this one. But that law, the ith index is violating because of the I minus 1th index. So if I minus 1th index is not in the picture, is not in our subarray, then we will not even consider that ith index. अब देखो यहाँ पर जैसे कि if you will take this subarray, according to our logic, you will say Abhinav, here 3 is violating the law because the value for that second index is 1. मतलब कि ये इसके पिछले वाले से एक बड़ा नहीं है. It is not 1 more than its previous element, but its previous element is not even considered. So when we will actually take array, let's say from index number 2 to index number 5, so I will not take the starting index. I will just take from here to here. Basically from, let's say if we're taking from I to j, then I will just consider from I plus 1 to j. Because when I'm considering from I plus 1 to j, so according to our logic, I have also covered I. Okay, because for every ith index, I have checked my I minus 1th index, right? So what I will do, now it's just a sliding window approach that will happen. Okay, so I will start my sliding window from the first. So you will see here that initially in my count, I have taken first k element. Okay, and if my count is 0, then the last element of that first k element will be my answer. Otherwise, minus will be my answer. So I will take my answer here somewhere. Okay, and I will take the first k elements where k is 3. I'm making this to handle. Yeah. Okay. This is my first subarray of. Now you can see here the count is 2 because there are two indexes which are violating our law. Two indexes which are violating our law. So then for this subarray answer will be minus 1. So whenever count will be more than 0, that means there are some indexes in the subarray that are violating the law which we want. So answer is minus 1. Then for every case what I will do, I will move forward for starting from k till last. तो मैं क्या करूँगा कि मैं एक इंडेक्स आगे बढ़. So when I'm moving forward, I have to first increase this value. So if this ARR of I, this is I, right? So if this I is actually is 1, I will increase my count. But it is not 1. It is not 1, so I will not increase my count. And now I will say, ये चला गया ना. And if this index is gone, this one was because of this index na. So if now I will say if the value of I minus k plus 1, this is, if you will see, if this is I and k is 3, so this will be I minus k plus 1. So if I minus k plus 1 is 1, so I will decrease my c. So now c will become 1 because as I said, when I'm considering this particular subarray, I will not consider this one because this one was because of this last index, right, which is not in the array. तो मतलब इस पर्टिकुलर सब एरे में सिर्फ एक इंडेक्स है जो वॉयलेट कर रहा है. देयर इज ओनली वन इंडेक्स इन दिस सब एरे व्हिच इज वॉयलेटिंग आवर लॉ, व्हिच इज दिस 3. 1 is not there because 2 is not included, right? But still, if there is even 1, we will not consider it. Answer will be minus 1 only. Okay, now we will again move forward. Now it came here. When it came here, it was 0, so nothing increased, and this is again 1, which is gone. अब देखो इस सब एरे में there is no index which is violating our law because our c became 0. Whenever I c became 0, then I will, in our answer, I will insert push back nums of I. So this nums of I, which is 5, will be inserted because for this subarray, it is not violating the law, it is fulfilling, and answer is 5. Okay. Again, I will move forward. Again, here c will be 0 only. So if c will be 0 again, for this 6 will be the answer. Again, I will move forward. Here 1 came. So now c will be 1. So it will be again minus 1. Whenever c is 1, minus 1. Okay. Move forward. Now c became 2. There are two violating indexes. And again c minus 1. And again, when I will go here, even if this will be gone, but it still will be minus 1. Right? So guys, this is how we are doing it in a kind of a, we have done, prefix sum or, sliding window mostly it is, right? But yeah, this is a very good problem, and you can see the time complexity and space complexity order of n in this particular case. The brute force approach can be order of n into k, but in this approach you can see our time complexity was order of n and our space complexity was also order of n. Okay, so I hope that you have got the understanding of this particular problem, which is find the power of k size subarray, right? How we have solved it. But still, if you have any doubt regarding this problem, you can ask that to me in the comment section, or you can join our Telegram channel to ask your doubt. Okay, amazing, amazing. Now let's move forward to the third problem, guys, which is maximum value sum by placing three rooks, right? So as I said, this problem is also having two versions, first and second. Second version, as I said previously, was expecting some better time complexity, which I was not able to solve. This problem that I've solved is using the time complexity of, I told right previously, n cube plus n square log n. This is a time complexity through which I have solved my C problem. You can say approx order of n cube only, right? But if I can solve it in order of n square log n, basically what I did here, I have first sorted my all the columns of every row, which took me n square log n. Maybe take m here. Here I am considering both my row and column as n only, right? And then I applied a dp on that, and that dp was taking order of n cube, right? So that is why it was around order of n cube. But yeah, if I can make this dp somehow to n square, then I think my submission can be submitted. But yeah, I was not able to solve it, or maybe there is some other approach also of solving it. Okay, I'm not sure about that, what that approach is, right? Cool, cool. So yeah, let's discuss this problem in detail now. So basically what the problem says is that you are having a 2D array, a board, okay, which is represented as a chessboard, they are saying, okay, and where every index of the board is actually having some value, okay. So every index of the board is having some value with it. Now what they are saying is the rooks in the same row or column attack each other, and you need to place three rooks on the chessboard such that the rooks do not attack each other. Okay, that is what they are saying. So basically the thing is that when you place a rook in a particular index, okay, in a particular cell basically, then in that same row, in that same column, you cannot place any another rook. Okay, let me give you an example. For example, ki this is your you know uh, chess. Let's take this much only, okay, and let's say if you have placed a rook here, for example, then you cannot place any rook in the same row or in the same column. That's the thing, okay. Anywhere else you can place, maybe you can place again here, and if you have placed it here, now you cannot place any other rook in this same row and in this same column. Then third rook you can maybe place here, right? And then you're, so basically you have to just place three rooks. You have to just place three rooks. But how you will place them? You have to place them in such a way that the position where they are placed, that should have the maximum value. For example, if I have placed in this way, if I have placed in this way, then my sum of value is, so this is 1 plus this is -3 and plus this is 2. So ultimately my sum is 0. But if you will see here, here I am placing at this place with 1, at this place with 1, and at this place with 2. So final sum we are getting is 4, right? So you have to place these three rooks in such a way so that they are in different rows and different columns, and their sum of value where they are placed is also maximized, right? This is the basic thing. Up, see guys, first is a I will tell you a first very brute force solution of it. Okay, brute force solution kya hoga? Let me explain a brute force solution. For that, what I will do, I will take here a grid actually. I will take here a grid like this. ठीक है. Okay, wait. Let me have equal partitions. Sorry. I'm not sure. Still, they are not equal, but okay, fine. And let's have it here. I even don't want equal size grid. Maybe I will remove this last part. Okay, so this is a grid basically that I am having. Okay, up what I will do here, that here we have to place three rooks, and let's say every every row and column will have some value. Okay, let's assume I'm not maybe placing any value. Okay, if you want I can also place, I can give some values: 2, -1, 5, -8, 6, 0, 9, 2, 1, 8, -5, 9, 6, 0, 2, 1, -8, -2, -5, -1, 0, -7, -3, 2, 1, 8, 6, 5, 9, 2, 1, 9, 8, 6 minus 5, for example. Okay. What will happen? You will pick a particular index. Okay. And when you pick a particular index in a particular row, okay, then you cannot take that same row or the same column, right? Because the very first thing that important here is that, see, maybe that, let's say most of you may think it is a greedy approach. Why greedy approach? Because you will say, okay, Abhinav, if I will take, what I will do, I will take the maximum from the first row and I will take that particular number. But no, it will not always work. For example, in the first row, this is the maximum number, and let's say you are taking this maximum number. Because you are taking this maximum number, now you cannot take any number in this row and in this column. Okay. But maybe it is a possibility, because here there was another number which was 9 present. Maybe not taking this 9 and taking this 9 was a better thing. Obviously, if you are not taking this 9, let's say आपने ये वाला 9 ले लिया, ठीक है, you are taking this 9. Because you are taking this 9 from this row, you cannot take this 9 from here. Let's say that, because we have to check for every combination. It's not a greedy approach, right? So let's say if you have taken this last 9, तो अब ये तो आप नहीं ले सकते हो. Let's say you will take the second maximum. You will say, okay, Abhinav, now I will take the second maximum. Maybe this was also not fine. Maybe that you have opt for this. Because of this, you cannot take this also. But third maximum you will definitely take, because for a third, because you need to just take 3 numbers now. So this third you will definitely take. So basically, you have to choose from the top 3 elements of every row, and for at max 3 row you have to choose. अब fourth element तो लोगे ही नहीं. Fourth element को लेने का मतलब ही नहीं. There is no sense for taking the fourth element. Okay, top maybe you will not take, because for that same column there is some other element that you must be taking, and maybe that is making better answer. Maybe second top also you will not take, but third top you will definitely take. Or either you will not take any element from that row. या तो ऐसा करो कि आप इस row से कोई element ले ही नहीं रहे हो, because you have other rows also. It's not a guarantee that from every row one element will come. You can also skip some row, right? You can also skip some row. Getting or not, right? So this is what the thing is here. This is what the problem is. That from every row, you will either take the first maximum, second maximum, or the third maximum. After that, you will not take. कोई सेंस नहीं बनता उस बात का. There is no sense of taking the fourth maximum. Why to take fourth maximum? Why you are skipping the top 3? Maybe you have to skip the first top one, maybe the second top, maybe the third top, but not all. So I will take all the combinations of first 3 elements from every row. कि अगर हम 9 लेते हैं तो क्या होता है, 6 लेते हैं तो क्या होता है, 5 लेते हैं तो क्या होता है. बट ऐसा केस कोई बनेगा ही नहीं. दैट केस विल नेवर कम that I am not taking 6, 5 and 6, 9, 6 and 5, but I am taking 2. Okay, no, why are you taking 2? If you have to consider this row, if you have to block this row, then why are you taking 2? Take 5, 6 or 9 ना. वो तो है ना, 2 क्यों ले रहे हो, right? So top 3 element we will take from every row. Either we will take top 3 or we will not take any element from that row. या तो मैं इस रो से एलिमेंट ले लेता हूँ, मैं इस रो पे आ जाता हूँ. Either, right? Do you got the sense now? Do you got the sense? Right? Obviously, when we want the maximum sum. So either, let's say if I have to consider element from there, let's say I'm taking this row. First case will be not take. Not take case will be that you are not taking this row. If you are not taking this row, then it's fine. Skip it and move forward. But if you are taking this row, so which element you should take? You should take the top element. But let's say because of some reason you cannot take the top element. Because top element is, let's say that row is already taken by someone, or maybe later on you want to take that column for some other row. Okay, skip it. Take the second top. Maybe second top is also not possible. Maybe it is already taken by someone, or let's say someone else will later take it. It's fine. But third you will obviously take, because if 2 columns are already done, then there's a third column, the last column which you should taking. And if all the 3 columns are done, then don't take that, just skip it. Are you getting? So basically we have to just concerned about top 3 element of every row. Okay. अब ये तो एक लॉजिक हुआ. Second logic is DP कैसे लगा रहे हैं. So see guys, DP how we are doing. First of all, from every row I will take the top 3 elements. So what I will do, every row I will sort in the ascending order, and along with that top 3 element I will include its index also, its column number also, because column number is also important, because once you are taking column number, you cannot take that same column again. Okay, so what I will do, first 9,6 will come, the max number 9,6. Then 6,4 will come. Then 5,2 will come. from this first row. ठीक है. From second 9, 2 will come. Then 8, 6 will come. Okay, and then finally 6, 1 will come. I'm just taking the top three number. Okay, here 2, 0 will come. Then 1, 1 will come. Then 0, 6 will come. These are the top three numbers. Then here 8, 4 will come. Then 6, 5 will come. Then 5, 6 will come. So every number with its column number. Okay, and then 9, 3 will come. Then 8, 2 will come, and then finally okay, there's 2, 9. हाँ, तो with 9, 6 will come, and then 8, 2 will come. Right? Amazing. तो अब देखो मैं क्या कर रहा हूँ यहाँ पर. And later on also, like I will sort for all the numbers, but I'm writing just 3 because that is what is needed. हमें बस top की 3 चाहिए. We will sort for the whole array. So you can see what I did. Initially what I did is, here in this particular question, I first of all taken an array. It is again a 2D array, but it's containing a pair. Why pair? Okay, let's have it here. हाँ, तो अब देखो हम क्या कर रहे हैं यहाँ पर. Initially what I'm doing is that I'm taking an array, and every array, and this is again a 2D vector, and every element of this 2D vector is having a pair. Why pair? Because it should contain a number and its column number also. Okay, तो मैंने सेम क्या किया, मैंने सेम बोल्ड वाला 2D array को in this matrix I have stored in this ARR, and when I'm storing for every row of this ARR, I'm storing it in the temp, and I am sorting it in descending order like this. I'm sorting it in a descending order. You can see इस तरीके से. So every row I will insert it in a temp along with the column number. You can see value and the column number, and then I'm sorting it in the descending order. Make sense? तो हमें को ऐसा है. So on, right? Now I have written this DP. So I have what I do. So DP state I have made -1. I will draw. So let's say DP कर क्या रहा है. पहले समझ DP क्या कर रहा है. So see, अब DP क्या कर रहा है. What I'm doing is that I'm starting from the first row. I'm starting from first row. When I'm in the first row, I have 3 things to do. Not 3 things. I have 2 things to do. Either I will not take this row. ये DP है, ठीक है. या तो मैं इस रो को नहीं लूंगा. I will not take this row, and I will just move to the I+1th row. That's the first case. ठीक है. Second case will be that you will take this row. Means you will take a column or a value from this row. But which value? So we know that it will be either of 3. 3 ही चेक करनी है, उसका आगे में चेक ही नहीं करनी है. या तो ये लो, या तो ये लो, या तो ये लो, या फिर लो ही मत. Move on. Not take. Okay. अब which will you will take? अभिनव ये लें या फिर ये लें, फिर ये लें. तो check for all, not just check for all 3 possible combination. Either take this, either take this, either take this, and for every possible combination move forward. और उसमें एक और चीज भी है कि we cannot take the column which we have taken already. We cannot take that column again which we have taken already. Let's say कि from here I have taken this, from here I have taken this. So these 2 columns are done. अब in the next row, let's say this row, I cannot take this column and this column. तो वो कहाँ पे स्टोर करेंगे? Okay, so you can see in my DP state what I did. In my DP state I have first taken a value called I, which is the current row where we are. Then I have taken first J, means the first column that I have taken. Then second column that I have taken. Because these last 2 columns which I have already taken, I cannot take this column again. And if I have not taken, then I can take. And third क्यों नहीं रखा? क्योंकि third हम ले लेंगे तो फिर तुम्हें क्वेश्चन रुक जाएगा ना. Once I get the third column, then question will stop. I will not even make the recursion call further because we got the 3 columns, 3 numbers, right? So up to 2 columns you have to store. But initially for the first row, there is no 2 columns I have taken before. I can take all the columns. I can consider all the columns. So initially you can see when I'm making the recursion call here, I made this both first column and second column -1, and my row I will start from 0, and I've passed this ARR matrix of pairs, right? अब देखो logic क्या लगेगा यहाँ पर. What will be the logic here? What I will do here, that initially, so when I will reach the end, then I will return a very low value, because let's say without taking 3 numbers, if I have just skipped and reached the last row out of the bound, that means कि हमारा आंसर int main होगा, मतलब बहुत छोटा नंबर होगा, we will not even consider it, right? And whenever we get a 3 value, हम तुरंत आंसर रिटर्न कर लेंगे अपना. तो you will understand this base case, don't worry. This is just a DP state I have handled. So you can see our 3 things will be changed: I, first j and second j. So for that I have taken DP state, okay, of that range. वो मैं हैंडल कर लिया. अब मेन आते लॉजिक पे. अब लॉजिक क्या है? लॉजिक इज वेरी बेसिक. First thing is that if my first j is -1, my first j -1 means that I have not taken any previous column till now. मेरा पहला j ही -1 है. मतलब let's say we are currently here. So currently here, my both first j and second j is -1 because I have not taken any column before. मैंने इसके लिए कोई column ही नहीं लिया है. So if I have not taken any column before, मतलब हम कोई भी column ले सकते हैं in the current row. Means I can take any column in the current row. So first thing is the not take case, that I am not taking any column from the current row and I'm just moving to the row I plus 1. तो मैं क्या कर रहा हूँ इस केस में? This is the not take case, that I'm not taking any column and I'm just moving to the next row. I'm just moving to the next row. ठीक है? Second thing is that I am taking this first column, ये वाली value. So when you're taking this column, so this 9 will be added in your answer. So you can see this 9, first element of this pair will be added in the answer because हम ले रहे हैं, and the second will become my first j because this is the first column that I have taken and this cannot be taken again. So my this ARR I0 second, this will become my first j for the next recursion call because I have considered that column and this column should not be considered again. Similarly, I'm checking for this also, which is ARR of I1 first and ARR of I1 second and second index also. Basically for all these 3 pairs कि मैंने पहले ये वाला रो लिया, तो 9 इज एडेड इन द आंसर और 6 आपने फर्स्ट इंडेक्स में डाल दी. भाई 6 हम ले चुके हैं, अब दोबारा 6 वाला कॉल नहीं लेना चाहिए. फिर ये लिया और सबके लिए सेपरेटली आई मेड द रिकर्जन कॉल. ठीक है? अब जब ये कॉल आगे कभी जाएगी जहां पर सेकंड जे इज -1, मीन फर्स्ट जे इज नॉट -1 बट सेकंड जे इज -1, दैट मीन्स कि someone has taken the first column. Let's say that I've taken this first column. So my first column means my first j is 6. My first j is 6 means I've taken the first column. Okay, my first j is 6. So if my first j is 6 means I cannot take this 6 again, but my second j is still -1 because I've just taken the one column above. So my second j is still -1. So when my second j is -1, I've taken the first j only. So again first case will be as it is, not take case. I will just move to the I plus 1 index, not take. Next thing will be that I will first, so again क्या करना है? Let's say अब हम इस column पे हैं. अब when I'm in this column, so the main thing is now I cannot take this 6th index. So again I will check for every 0, 1 and 2, all the first 3 numbers, but I will not take that particular number or that particular cell which is having the column number 6. For example this, ये हम नहीं लेंगे because इसका भी column number 6 ही है. तो हम क्या करेंगे? I will check if for the current its second means the column is not equal to the first j, हमने उसको ऑलरेडी नहीं ले रखा है, then only consider it and then make this as the second. Let's say अगर हम ये ले रहे हैं this element, that means now this 0 will become my second j for the next recursion call and this 2 will be added in the answer, but we can only take it if it is not equal to first j. Same, if this is not equal to first j, take it, add in the answer. If this is not equal to first, तो हम लोग again उस रो के लिए तीनों को चेक करेंगे. If its index, if its column number is not equal to first j, means we can take it as the second j. So add the value and make it as the second j for the next recursion call. And if my first j and second j both are not equal to -1, means we have taken both the columns already before. मान लो हमने ये भी ले लिया और ये भी ले लिया है. My first j is 6, second j is 0. Means now I cannot take the column 0 and column 6 in the later row. अब let's say हम इस रो पे आ गए for example. तो now I can not take the 0th column also and the 6th column also. Let's say इस वाले पे तो यहाँ पे देखो 6 से हम इसको नहीं ले सकते. तो now I will check for both the case that if my ARR second is not equal to first j and also not equal to second j, means if the current cell that I am considering, if its column number is not equal to first j and second j, then only you can consider it. And when you will consider this third value, अब आप कोई भी अगली recursion call नहीं मारोगे because you just need 3 numbers ना. You will just take it and stop. No more recursion call happening. And every 0 के लिए भी चेक करोगे, इसके लिए भी, इसके लिए भी. If column number is not equal to first j or second j and second j, then consider it and move forward. And whatever is the maximum among all the cases, that will be our answer. And then you can see the range of this I will be up to n, which is 105 in max case. First G and second G is also up to n, but because initially we are initializing it with -1, so I'm taking it +1 because of minus का 0 हो जाए फिर in indexing, right? And you can see it here. I'm first made my whole DP to -1 and then I'm just considering it here. Okay, so this is what we are doing here, guys. This particular code. I hope that you've gotten a sense of this particular solution. Fourth one I was actually able to solve. So this, if you will see, this is the order of n cube. N cube is for this DP. DP is having n cube, okay? And this sorting every column of every row, basically every row is will take n square log n. Or more specifically, अगर हम n into m माने, so it will be order of n into m plus n into m into log m. So it will be order of nm square plus nm log m. ये बोल सकते हैं हमने यहाँ पे मैंने n को equal to m ही मान लिया, right? Cool, guys. So I hope that you have understood this particular solution. And yeah, space complexity is obviously n into m only. Okay, this is time complexity and this is space complexity. Okay, I hope that you got understand this particular solution. Still, if you're in doubt, you can ask that to me in a comment section or you can join Telegram channel to ask your doubt. Thank you.